Hi, in this video, I'm going to talk about geometric mean. This is a request by a few students, and so let's go over it. The length of the altitude of a hypotenuse of a right triangle is the geometric mean. Here's the key word here. Is the geometric mean of the length of the segment, so length of a segment, and length of a segment of the hypotenuse. So length of a segment of hypotenuse. So the length of the altitude with length of altitude, the keyword here. So my altitude, this is a right triangle. Given a right triangle, what is saying here, the altitude draw from the right angle to the hypotenuse, which is CD. So number one says CD is the geometric mean, of, let me write it better. Geometric mean of the length of the segment. Again, this is the length of segment is AD. In this case, length of segments could be AD, it can also be dB. So we're talking about the hypotenuse or the altitude. Let me use different color. So this altitude CD is the geometric mean of the segment and of the hypotenuse. So so let's write it. Okay, so CD is the geometric mean of AD and DB. Okay, geometric mean of, let me write it, AD and DB. That's the first one. Okay, so length of the altitude to the hypotenuse of a right triangle is the geometric mean of length of the segment, which is the segments of AD and DB. So that's what it means. So CD is a geometric mean of AD and DB. So let me use the same color here so you see it, DB. Well, what does that mean by geometric mean though? Okay, so being the geometric mean tells me you can write a proportion. So CD, I can write it equal over some here equal to something over CD. So CD is the geometric mean. That's what it means here. Well, the geometric mean of what? Of AD and DB. Okay, so that's one geometric mean equation I could write. Now let's look at the second theorem. Okay. In the second theorem, it says that the length of each leg, okay, let's kind of understand each one at a time. So with something, it's good to highlight it, underline it, make it easier for yourself to see. So in the second one, this one telling me here, the length of each leg, okay, so I'm now referring to the leg. Length of each leg is the geometric mean. The length of each leg, this is one leg here. So the length of each leg of a right triangle is the geometric mean of the length of the hypotenuse and the length of the segment adjacent to that leg. Okay, so this is a info here. So we know that's one part at a time. So length of each leg of right triangle. So let's do one of them. So we're saying that AC is a geometric mean, is the geometric mean. Let me write that. Oh, it's a geometric mean of something. Well, what's a geometric mean of? I'll write AC first. I know AC is a geometric mean. Now let's start with AC. Geometric mean of what? Well, AC, the leg is a geometric mean of the length of hypotenuse. Length of the hypotenuse is just AB. AB is the hypotenuse here. So AB, okay. And the length of a segment of the hypotenuse adjacent to the leg. So AD and DB are the segments, and the one that adjacent to the leg is, in this case here, is AD. So AD. Okay, so that is one I could write. Now I can also write one more. Number 3, geometric mean. So instead of saying AC as the leg, I can say, CB here is also the leg. So I could say CB here is a geometric mean. So CB is also a geometric mean. Well, CB a geometric mean of what? Of the hypotenuse, in this case AB, and the segment adjacent to that leg, which is BD. Okay, so there are three geometric mean equations you could write using the two theorem here. So depending on which one you want to use in the solve, you might write differently, depending on what's given. So let's do one exercise using the geometric mean. So here for the drawing below, find x and y. Notice that this is a right angle here. So therefore, in any right triangle, I could use the geometric mean. So this is a right triangle, so I could do the geometric mean here. So let's do it. So first one is find x and y. Well, let's locate the thing that I want here. I'm given an altitude. I could write altitude geometry mean using the altitude. But notice the altitude length, I don't know anything about it. So, but now I do know the leg. So I know that the leg here, this is this leg. We say in the theorem here, the leg is a geometric mean of the segment and the hypotenuse, which the hypotenuse in this case is the whole thing, right? And which is x. Okay, so let me just highlight so you see it. So here, so this is x. So I can rewrite this. I can say 6, which is the leg here. 6 is the geometric mean of the segment of the hypotenuse. In this case, is x. Okay, and the segment adjacent to that leg. Again, the segment adjacent to that leg here is y. Okay, so it tells me I could write this as a ratio. So I'm going to write it. So I say, well, 6 is geometric mean. So 6 is geometric mean, tells me 6 is going to be in the cross product of what? Of x and y. Well, x and y. Notice I have x and y in one equation. So I want to rewrite it so I can solve in one equation only. So if this is y, this is x, can I somehow rewriting y and x using what is given? Notice that x here is just equal to y plus 9. So I could say, well, x is y plus 9. I'm going to replace x with y plus 9. Or I can also solve for y here. Notice that the y. I can also rewrite it as x minus 9. So either way, I want one variable only. So I can rewrite this as 6 over x is equal to y. Oh, I'm going to write x, not y. Let me write x again. So 6 over y plus 9, rewriting the x as 9 plus 9, equal to y over 6. Now I have one variable and one equation I can solve for y. And once I solve for y, I can substitute in solve for x. So here's a matter of algebra here. So common mistake students forget to see is when you do cross multiply, make sure the y times both the 9 and the y here. So let me rewrite it. This is y. Let me write it. Y times y plus 9 is equal to 36. 6 and 6 give me 36. So this is y squared plus 9y. Okay, don't forget the y, go to both of them, equal to 36. So I can subtract 36 to both sides. So y squared plus 9y minus 36 is going to give me 0. Now this is our algebra equation here. It's quadratic equation. Which is solving quadratic equation. We could do it, we can either do it by substitution. You can also do it by using the quadratic formula, or not quadratic substitution, but factoring. I mean, you could do factoring and you can do quadratic formula, or another method, whichever method that is easier for you to do. So here I'm gonna do factoring. And notice that is 36 is I can write 36 a factor here. So we call in algebra classes factoring. Could, if you forget, you could do the X method, we call it, where 36, negative 36, the constant goes to the bottom, with a middle term, with a y term gonna go to the top. We say, if look, we look for two numbers. When I multiply, I get negative 6. When I add or subtract, I get 9. So these two numbers are 12 and 13. 12 and 3, I mean. 12 and 3, but I want one of them to be negative. Well, 12, I want the product of positive numbers, so I want a 3 to be negative, because 12 minus 3 give me a 9. So that's my cross product. So I can rewrite this as, let me rewrite it over here. So rewrite this over here. So now I can have, this becomes 9, this is y plus 12 times y minus 3 equal to 0. Now set each factor equals 0 and solve. So y plus 12 give me 0. Y equal to negative 12. And y minus 3 give me 0. So y equal to 3. Notice that I have a negative length here. Y is referring to the length of a triangle, so it cannot be negative. So this one's gone. So my y here have to be equal to 3, a positive length. Now I'm going to use the y to solve for x. Here we said x is equal to y plus 9. So y is 3, so 3 plus 9 going to give me 12. So I have my answers y equal to 3 and x equal to 12. Okay, let me highlight my answer here. So we just use the geometric mean here to solve one over length. Okay, so let me just put it in one screen so you can see the whole thing. All right, thank you for watching. I'll see you next time.